Yes, and with that, I'd like to introduce the third and final speaker of the session. Bruns will give us some overview of embedded wires, and we're looking forward to it.
Yes. Okay. Hello. Thank you for joining. I know two things. It's pretty warm in here, and I'll be not that fast as my colleague from Trusco. That's what I know up to now. So you joined the session of ruhlamat. Short intro is that we changed our name from 1st of October. So when you leave, you will have seen a presentation of Maxmatec. Short story: we sold our Chinese subsidiary, and they had the need to use also the brand ruhlamat, and that's the reason why we changed our name. We are still in Marksuhl, in our headquarters in the middle of Germany. It's in the south of Eisenach in Thuringia. What are we doing in general? We are a machine builder, special machinery, individual machinery according to specification of customers, and also OEM business means serial production for customers who sell machines on the market. So that's the other core we have, and that's the history of the wire embedding since over 20 years. Wire embedding used for antennas, for the inlays for passports, and also for credit cards. We are on the exhibition floor. Of course, you can see there some samples. So it's a well-introduced process in general. Here you see our modular machinery we offer to our customers in this area. So in the core, we are a manufacturer of assembly systems. We have 270 employees, and we do this over 30 years. And have also our environmental responsibility with a wind turbine and photovoltaic, of course. What are we coming from regarding this meeting, this conference here? We know the screen printing, normally in 2D applications. We know also these MID versions coming out of tooling and tools. And what we also know for flexible foils especially is the flex PCB technology. And that's our intent to bring in some new developments regarding to transform the wire embedding also into assembly and automotive solutions. So what's the process like? Especially mentioned is we only need two things. We need the wire as the core functional element that you need for your application, and we need the substrate. Substrate, we call it in general, can be flexible like foils, thin to 20 or 50 microns. Can also be a solid stuff and a 3D geometry. We have no waste and no chemicals to produce, only the two parts which you want to gain for your product. We work with a sonotrode. The wire comes out of the sonotrode, is pressed with a basic force on the material, and then we have the ultrasonic vibration, which brings in heat into the connection between substrate and wire. The substrate melts up. That means we need thermoplastics, that was the word. Thermoplastics who are meltable to implement the wire into the substrate. We talk about wires between 50 micron and around about 200 microns. We are working on thicker wires, that's the challenges I will mention. And we embed the wire around about 50%. Depends also on the application. We can talk with customers. We have a laboratory in which we check the possibilities with your special product. So the normal production chain for 2D is you have a foil or a solid part, then you do the embedding, and then you do the next process. That's a cover or labeling or lamination or something like that. In 3D, it's a little bit different. We have solid parts on which we can embed directly, and at the end, of course, there has to be some kind of protection for the wire, which can be also molding or lamination. In the special application of foils, there can be two possibilities. When you want to have a 3D shape, you bring in the wire at first and then you do some forming, but you have to recognize what is done in the forming, how much the wire is stressed. We have some experiences in that, but normally said beneath, the product specification and the product development is on